let me try part B. Okay, let me make the normal distribution. I'm sorry, the binomial distribution is again the binomial distribution is n equal 500, and the probability of success is 0.80 here. Yep. So we have a normal distribution as a mean equal to 500 times is 0.8, which was 400, and the standard deviation will be n times probability times 1 minus the probability, so which was 8.94. So now we have a normal distribution approximately. So let me make the normal distribution here. Mean was 400 in the middle, and the standard deviation is 8.94. Okay, so let me set up the normal distribution approximately. And now in part B, we need a probability is between 375 and 425. Yeah, we need a probability is between 375 and 475. Always for this normal approximation, we just adjust the range. So it's minus 0.5, and here is the add 0.5. So always we make it's a little bit wider range. So now just a second. Yes, the z-score at 374.5 will be take off the mean 400, then divided by the standard deviation is 8.94, then it will be negative 2.85. As also as we need the other one at 425.5, in the same way it's minus 400 divided by 8.94, that will be positive 2.85. Now you can see the z-scores. The left one is the negative 2.85, and the right one is a positive, is 2.85, because the distance from the mean is exactly same. It was 25, that was a 25. Yeah, so this way we added 25, and this way we subtract is 25 to get 375 and 425. So because of that, we are going to have exactly same the two z-scores. Is the left one is the negative 2.85, and the right one is the positive is a 2.85. So let me summarize again. Is it here? Right, so now we have a normal distribution. At the beginning, even we had the binomial distribution, but approximately now we have a normal distribution. It's a 400, and the standard deviation equal to 8.94, and we need the probability is between 375 and 425, but for the approximation, we have to adjust this a little bit, so we just make the wider range between 374.5 and 425.5. And then now we take the two z-scores. At 374.5 was as a negative 2.85, and the other one at 425.5 was at positive 2.85. Then now we are going to take two probabilities here. It's less than negative 2.85, and also is another, the left hand side probability is less than positive 2.85 from the z-table. From the z-table, at a z-score negative 2.85, there is a probability 0.0022. And the other one is another, at another the z-score 2.8 and 5. There is a probability, it's a 0.9978. And now for the probability in the middle, then we just take the difference as between the two probabilities. It will be 0.9978 minus 0.0022 will be 0.9954. It's a 0.9954. Let me rewrite. It's a 0.9954 will be the probabilities between these two scores approximately from the normal distribution. So please remember, you have to adjust a little bit, take the a little bit wider, is additionally is here and there, and approximately we can take the probability is between, yeah, is this range. That is a 0.99 is a 54. Or another way, we knew this one is that this one will be same as 0.0022. So even we can take the probability in the middle, 0.9954, can be from 1 minus twice 0.002. 0.0022. So either way, this one is traditionally we just take the two probabilities to the left and take the difference, or because the normal distribution is symmetrical, so either way, yeah, we can take the probability as a point, it's a 99, it's a 54 in the middle.